So there are at least two ways to do this question, and I'll start with this relationship. This is 3 times that of CD, so I'll call that x. Radius here is 3 centimeters, so that's 3. This is 3. This is our perpendicular distance, and that's also the height of this trapezoid. So its area would be half at the two bases times the height, which is 6. So that would be 12x. So the key thing is to find out what x is. And that's going to come from this here, if you draw this perpendicular. And we need to create a right triangle somewhere. So this is the right triangle I'll create. That whole thing is 3x. So this part, let me call that E. CE is 2x. This we know is 6. That's the diameter. And then I just need to relate this hypotenuse. So if we look at this point B, is making these two tangents here. And you end up with these two triangles that are congruent to each other. And this length here, because that's 3, is 3x minus 3. That means that this length is also 3x minus 3. I need the entire hypotenuse. If I come to this triangle, these two triangles here, again, this length is x minus 3. Why? Because that is the radius 3, and that whole thing is x. That means this is x minus 3. So now I have my dimensions for this right triangle, and I can apply the Pythagorean theorem. This is 4x minus 6. If I add those two, that's your hypotenuse, squared is equal to 2x squared plus 6 squared. And you'll notice that I can factor out a 2 here. That will become 2 squared. And same thing here, 2 squared, and then 2 squared, 3 squared. This is just to kind of reduce these terms. So that's my quadratic. I'll square that. 4x squared plus 9 minus 12x equal to x squared plus 9. You'll see the 9 drops out. I end up with 3x squared minus 12x equal to 0. And that means x has to be 4, can't be 0. That means the area is 12 times 4 is 48. So, I mean, it is still hard to kind of come up with that relationship, especially under exam conditions. So this is kind of how I actually did it. Now, there is, of course, always easier ways to do these questions, but that's after the fact. And that has to do with figuring out similarity here. So if I were to create these triangles here, and that's perpendicular as well. So if that's theta, this is theta. These two are identical because that's radius. This is radius. These are two right triangles, and they share the hypotenuse. So that's why both the angles are theta. So that's 90 minus theta. This is 90 minus theta. And we do the same thing for these two triangles here. They're also congruent, these two. Why? Because they share the hypotenuse here. They're both right triangles. And this is radius here. So if this is alpha, that's alpha. You'll see this will be theta. And the reason is, if this is a straight line, so all these angles, these two, which is 180 minus 2 theta plus 2 alpha, has to add up to 180. There might be even easier way to argue this, but that means that alpha is theta. So that means that this triangle is similar to that triangle. And so if I look at, now this is, I can replace that with theta. We know that this is x minus 3. As I said earlier, this is x. So if we do the ratio, that's opposite theta, x minus 3 over 3. That has to be the same as 3 over this length here, which is 3x minus 3. So that must equal. So that's the relationship from similarity. I can simplify that 1 over x minus 1 and then solve this equation, cross multiply. And then that becomes x squared minus 4x plus 3 equal to 3. That drops out. And again, you'll see you get x equal to 4. So this one is a little bit easier, but I think at least for me it was harder to spot this. But I think there was another question in another slot where you had that similar structure. So keep an eye on these types of questions where you have from a point outside the circle, you have two tangents and the similarities. So that might show up in other questions as well. So to summarize, x is 4. We're back to our area, 12 times 4, which is 48. Choice A.